Hi, everyone. My name is Jamie Harbin, and I work at Dalhousie University.
And I'm Dan Kelly. I also work at Dalhousie University, which is in Halifax, Nova Scotia. This is video 10 of a series that we have about an R package that we've written called argoFloats. And this one is about using adjusted data streams. You can see on the bottom here. I'm just showing you here a page from the GitHub website for this. And when this video is finished and put up on YouTube, we'll add a link just like this so you can get it from that method. Right, so first talk a little bit about what adjusted means. So with Argo data, you can have, well, there's a couple of things. One is that Argo data are combined with flags, and the flags indicate whether data of high or low quality. And it seems that sometimes paired with the actual fields, let's say the temperature field, there may be another field called temperature adjusted in the raw data. And sometimes that's done by obeying the flags. Like the flag might be that they use interpolation to get across a bad data point. That's one thing that's done for adjusted. And the other thing that could be done for adjusted fields is, I'll say, like an algorithmic change. A change in which they say, oh, this sensor is getting pressure out by 5%. I just made that up. And then so we'll just multiply it by 1.05 to increase it by 5% or something. Or perhaps to use a different formula for the oxygen concentration. So these are examples of adjusted fields. Not all Argo data have adjusted fields in them. And sometimes, it's very confusing, sometimes the adjusted fields consist of nothing but NA values. So maybe, Jamie, if I could ask you to pop over to your screen.
Sure.
I'll stop my sharing. So I think you should be able to show your screen.
Okay, so I think you can see that now.
I can see it, yeah. So over on the right-hand side is a little diagram that comes up. If you do !useAdjusted, it gives you some help. And you know, and can you scroll to the top of the help, Jamie?
Yeah, for sure.
Yeah, so it's fairly detailed, and there's a bunch of arguments, and the actual work is done using a function in the OCE package called preferAdjusted. It's a funny function. What it does is it simply sets a flag in the metadata saying, well, the user wants to use adjusted. Whenever there's adjusted data, they would like to use adjusted. But here we run into a trick. And can you scroll down to the diagram? Mm-hmm. And the trick is sometimes not always, but sometimes the adjusted parameter values, like param in this diagram means temperature, salinity, oxygen, so forth. Sometimes they're all NA. Well, even though the user might think, well, there's adjusted and that's probably the right thing to do. Well, I don't think it is if all the numbers are NA. So we have arguments to get around that. And this is a fairly complicated flowchart that explains the details of it. We have an argument called fallback. And maybe I'm going to say that it would require a little bit of time to explain this. What we're trying to do by the default values is to, if you say that you want to use the adjusted, it will use the adjusted value when you look things up with the square bracket notation, which you're going to see in a minute when Jamie shows you code. But it will, by default, it will refuse to do that if it's all NA values. You can make it, you can force it to use whatever it is in the adjusted, even if it's NA, if you want to. So this is a way of getting something sensible by default, but if you're sort of a power user, you can just get straight to the data. Okay, Jamie, now we can maybe go to you and you can explain the code a little bit.
Sure. So basically what we plan to do today is just show the difference between what we call sometimes raw data, so that's not using the adjusted, and then versus the adjusted data, just so you can really see the difference. And we're really just using basic R tools here. So I'm just gonna load up our package, and then line 2, what we're doing is just using a built-in file that we have within our package. That would be the same, so you can see the ID number here as well as the cycle number. So you could go about it by getting your index, subsetting by the specific ID, the specific cycle, get profiles, read profiles. So it's really the same stuff that we've been doing in all the other videos. But when I make line 2 happen, it's just creating an Argos type object. And then line 3, so this is our new function that we're showing today, and we're calling it adjusted. That's just applying this useAdjusted to this raw Argos type. And then all we're doing in the next few lines is really just pulling out the parameters that we want. So in the raw, we want the oxygen and the pressure. And then we're doing the exact same thing for the adjusted in the next 2 lines. So line 8, again, as I mentioned, it's really just basic our properties. We're just setting our xlim. And then 9 through, I guess, 13, we're just creating a plot. You'll see it pop up here. And this is just the raw data, I believe. Yep, the raw data. We'll get the legend at the end. And then on top of that, we're just plotting the adjusted. And we just did different symbols, so you're able to differentiate between the two. And just for completeness, we're going to have the legend there. So you can see that the raw is the black and the adjusted is the red. So really the point of this video was just to demonstrate there is a difference between the two. Is there anything that you want to follow up with on that, Dan?
Yeah, maybe I'll say that in line 4 at seek, and following, we're using unlist. And that's because when you do the square bracket notation there, it's going to return a list. In this particular case, we only have one profile in this data set, but because we just read one profile, but oftentimes you might have a dozen or hundreds of them. And let's suppose you have a dozen just for a number. Then if you do raw square bracket oxygen, it'll return a list, and that list will have a dozen elements, and each one will be a matrix holding the oxygen. So in this case, we're just using a single profile, so we're unlisting it just for convenience in plotting. That's all that is. Otherwise, line 9 would be trying to plot a list, and that's handled differently in R. So we're just making it into a vector, that's all. So that's, I think, about all I had to say. If you had anything else, Jamie?
Yeah, I think that's it too. Maybe the only other thing to mention is at this point, the user could use basic R functions to, maybe calculate the percent difference between the two, if it's significant, things like that. But yeah, this was really all we wanted to show for this video.
Yeah, actually, an exercise for the viewer might be to do a linear plot. A point plot, whatever you call that. A plot of a raw oxygen versus adjusted oxygen, and see whether, I don't know, it might even look linear. And you might even try using LM to see if it is linear. You might find out what I found out about that, but I'm just going to leave that as yeah, that's right. That's right. Okay, so that was it for this video. We're thinking of making another video about a Shiny app that we're working on to help visualize some data in a simple way. And whether that will be next week or a few weeks from now is not clear, but there's more to come, folks. Don't give up on the channel yet.
Thanks, everybody.
Thanks. Bye-bye.